All right, good afternoon, everyone. I hope you guys have had a wonderful lunch. You're all awake and you have your coffees. We'll start our presentation, Resilience Design and Infrastructure, Transit Infrastructure, and our case will be related to the 207 Street Yard, the yard that you see on the screen. All right, introductions. This presentation is brought to you by the AAA, Alto Dogan, Eamon Mucklis, Anthony Falcone. I'll start with myself. I'm Eamon Mucklis. I work with the Metropolitan Transportation Authority. I'm a project executive and a senior director. And I oversaw the construction of the 207 Street Yard Resiliency Project. My colleagues and mentors, Alto Dogan, he's a senior project executive for CAC Industry, a local contractor, utility contractor here in New York. And the brilliant engineer, one of the most brilliant civil engineers I know, Anthony Falcone. He's a professional associate and a senior project manager with HDR. And today we're talking about floods, a topic that keeps coming because hurricanes are the most occurring natural disaster or natural phenom. All of you remember Hurricane Sandy. It's about 12 years ago, happened 12 years ago. I've always told my story with Hurricane Sandy. I had moved from New Hampshire to New York within a week. I had to surf out of my apartment in Shore Parkway. Last year, my wife was pregnant, and she asked me, what do you want to call our daughter? And the first thought was Sandy, because I've been working on hurricane and climate adaptation for 10 years now. I could tell you her eyes were so mad. I thought that I'm going to have more impact than Sandy on my house. So I didn't tell her what was the second choice. The second choice was a flood. But we moved and we called the daughter Jenna, who's 5 months old right now. Again, we'll talk about floods. And in our case, it will be 207 Street Yard. I'm sorry, I went backwards. And when I talk about floods, everybody knows everything about floods. We recently have Hurricane Helene that brought destruction to Florida as well as Georgia and North Carolina. Before that, Milton. And locally here, we had Hurricane Ida, where we had a lot of rainwater going to the subway system. Again, the subway system has the lowest point in almost every neighborhood and zip code in New York City. So we are affected by floods and rainwater, intense rain events. Severely, and that impact the economy, the well-being of people, and our ability to connect people from point A to B. Again, we have impact on our infrastructure, and it is not just the stations that you see and the trains that moves you and connects you, but also the yards, which I'll talk a little bit about our assets, and I will talk about how we focus on our response, which is what I do, a capital approach to preventing floods or or making the subway more resilient. So we plan, design, and construct resilient measures and structures. 10 years ago, when I joined the MTA, I worked with folks that are in the room, such as Dan Weiss, Anthony, who's behind me, and Alto. We started as researchers figuring out what we could do for this unique environment, 120 years old. At the time, it was 110 years old. 120 years old system built by 3 different operators to different standards with different structures, and with a lot of requirements, how we can navigate the system and build some resiliency in the system. We worked, as I said, on the planning, designing, and construction, and on the process improvement and how we deploy for a flood event. We have 277 underground stations. Those are the most prone to flooding. We have the underriver tubes or the tunnels, and those tunnels have fan plants that sit on each end of the tunnel, which is a giant access hatch or an access point for water to get in. We also have 39 yards, terminal shops, and 85 miles of tracks, and we'll be talking about one of the largest yards. It's the second largest for the MTA. That's the 207 Street Yard. We of course came up with, since Hurricane Sandy, we came up with different ways to action plans and ways to combat the rainwater, as well as that's flash flooding, as well as coastal flooding. And when we first started, we did what we call the near-term improvement. That is solutions that are off the shelf. Again, as I mentioned, hurricanes and storms, they existed forever. They are increasing in impact and intensity, of course, with more urbanization and with more folks going towards the water bodies, living on water bodies. So we see more and more impact from floods. So when we started thinking about that, what did the Mesopotamian do? Because they flooded as well, and they did what we call flood logs, right? A very simple technology. They just stacked logs to protect. So we started with the near-term improvement. That's right after Hurricane Sandy. Then we started developing what we call the long-term improvements. Those are what you see, the marine doors that were introduced to the subway, flood walls, as well as mechanical closure devices and different type of devices to protect from floods. We also looked at, just like when you look at risk, avoidance is the first one. We were trying to protect from water getting in, but also we were trying to share some of those liabilities. So we got insurance. We asked our contractors to get insurance when they work, right? And we tried to stay with a project that produced a passive solution for floods, so we don't have to deploy. We don't have to go to the subway system and expend labor power to deploy. Here you can see the graphic is a sensitivity analysis where we do look at the area, we look at the research that we do, the hydrological research that we do, and then the different solutions that we have, and we select the best solution for us. I'll turn it over to Anthony Falcone to talk a little bit about the design.
Cute. All right, some orientation first for 207th Street Yard. This is at the north end of Manhattan. North is to the right. The north end is 215th Street. The south end is 207th Street. We're bound on the west by 10th Avenue and on the east by the Harlem River. The yard is approximately 40 acres in size. That one big building in the middle by itself is 8 acres just by one building alone. The yard was built in 1927. Before the yard was built, there were a number of sewers in the area. Combined sewers are in yellow. They're brick, anywhere from 36 inches to 54 inches. There's also an interceptor sewer that runs north through south of the yard, 24-inch diameter. And where the interceptor intersects with the combined sewers, that's where those two regulators are, N9 and N10. During dry weather flow, the combined sewers drop into the interceptor. And during wet weather, it's a combined sewer overflow. The water goes out to the river. The flooding from Hurricane Sandy did not overtop the seawall in a dramatic fashion in 2012. It actually was much more insidious. It backed up into this sewer system. It backed up through the system to the yard drains that are right by the yard portal at the very south end of the station of the yard, and it flooded that portal and the tunnel thereafter. So New York City Transit came to us and said, design something such that this does not happen again. And the first thing that we did was design a flood wall around the yard. Second factor there is we also designed a flood gate by the portal. Third thing we did is put in a seepage cutoff wall to deal with any infiltration under that flood wall. And the fourth thing we did is we said, okay, every one of those sewers and regulators and tie gates, we were going to seal them off because we created this bathtub. We want to prevent the water from welling up inside of it. And DEP said no. DEP said no because you are prohibiting us from actually maintaining those structures. We have to go there at the very least once a month. And more often, if there's a problem, middle of the night, we have to have access to these regulators and tide gates. So the compromise was reached where New York City Transit would move the interceptor out of the yard and the regulators. And in compensation for that, New York City Transit would be allowed to seal off all those manholes. So what that looks like is now the interceptor sewer makes a hard right-hand turn on 215th Street and then goes south along 10th Avenue. And those regulators that were once in the yard are now outside of the yard. But before we could even start this design, we had to do our due diligence to make sure that the changes that we're making to the sewer system are not going to adversely affect the rest of the neighborhood. We ran a hydrologic and hydraulic analysis using DEP's own InfoWorks model for the area. We refined it just for the yard. We did flow metering to calibrate our model, make sure that it's reflecting reality, and then we overlaid our new sewer layout to it. And our analysis showed that the hydraulic grade line, the difference in height of the water in the sewer, is less than 1 inch post versus previous to the construction. That means, in actuality, that's less than the accuracy and the precision of the model. So we're in the right zone in terms of not affecting the adjacent neighborhoods. Next thing we did for the design is look at the profile. And that green line at the bottom shows that the sewer does go downhill. That's not a problem. It can work by gravity. What's not so great is that the topography is not very helpful here. We start off anywhere from 19 feet deep all the way up to 35 feet deep to install this sewer. And the solution we came up with is microtunneling that sewer. That solves two problems. Number one, it solves the issue of being able to get so deep to install this sewer. And number two, on 10th Avenue, you have an elevated subway over your head. So you're not going to be doing a 35-foot deep open trench excavation next to an elevated subway. It's never going to work. Once the sewer is outside of the yard and those regulators are outside of the yard, the next step that we have to deal with is the sanitary drainage inside the yard. That means every single floor drain, slop sink, bathroom, shower, every one of those things have got to be traced down, tracked, and either we can prove that it goes out to the streets by gravity, or we had to send it to 2 intermediate pump stations and then pump it out of the system, out of the yard, into the combined sewers outside. And once that's done, what you're left with is those last 2 or 3 sewers inside of the yard, which are now downstream of the regulators. They're combined sewer overflow pipes. However, during the storm surge event, when you have water outside of that flood wall 14, 16 feet high, that pressure is pushing back inside this system. And these are brick sewers. Brick works great in compression, but is horrible in tension. Number one. Number two, if it's raining cats and dogs and you have a flood condition outside, all of that soil on the inside of the yard is all saturated. So the shear stress of that soil has been reduced, because now you don't have all that weight of the soil, but you also have you have to subtract the buoyant force of that soil. So our solution there was to do cured in place liners for all of these sewers. Number one. Number two, every manhole that remains, we reinforced it on the inside with gunite it. Third thing we did is every manhole that was not necessary, that was beyond the minimum required for that size of sewer, we abandoned it. And then the fourth thing we did is for the manholes that did remain, we installed bolted down manhole covers, and we also installed a cast-in-place concrete lid on top of it to act as a counterweight in case there's ever an uplift force over there. This pretty much defines the design intent. I'll turn it over to Alto Dogan now to talk about the actual construction and the construction challenges.
Good afternoon, everybody. Thank you, Eamon and Tony. After Eamon and Tony, they did their due diligence. Now we came into picture, CIC Industries, to build. The challenges, do you have the... Challenges, Eamon mentioned that before. It's an old infrastructure, about 100 years old. And the limited space, both above and below ground, especially out on the street. You have the elevated structure, like Tony mentioned before, and you have all the adjacent buildings right next to the structure. Navigating around the yard and shops. This is the second largest yard in New York City system, subway system. So it's busy yard. We had to navigate around them, as well as other contractors. They're working inside the yard. Field conditions keep changing, unforeseen, and specifically inside the yard. The system was built, again, 100 years ago, and then tracks were laid over it. So it's, even though like we have technology to locate them, sometimes there were a lot of unforeseen conditions. And the pandemic. This job was awarded in 2019. And we had to start our construction right in the middle of the pandemic. Construction never stopped. We were the essential workers, and we had to work. So slightly after the pandemic, all those outdoor seatings started popping up. Every restaurants have outdoor seatings, and they were right on top of where we're supposed to work and locate the utilities. Availability of MTA resources already short, and the pandemic also did not help. Inside the yard, we have to work with the track outages. We have to take the track out of service, remove the track, do our work, and put the track back. And also our impact on the subway and maintenance operations. I'd like to elaborate more on those, on a couple of things. I can separate this into 2 areas. We did street work, and upon completing our street work, we had to go inside the yard and start abandoning or taking out existing service, existing utilities or sewer out of service. So I mentioned the outdoor restaurant seating created during the pandemic. We had to resequence our work. throughout them. We work with the community board closely, Amen and Tony, and then we try to impact them as less as possible. Also, unforeseen utility interferences. I mean, working out on the street in New York City, you have Con Ed Gas, Con Ed Electric, ECS, Verizon, level 3 cables, you name it. So our job was to relocate them, but we found also a lot of them that are not shown or not known. Also, like Tony mentioned before, we have elevated structure overhead. And as you can see on the photo, we have to do this 30, 40 feet excavation right adjacent to that track, and train is running over it, you can see. And then on the right side, there are adjacent buildings. In this case, it's a parking lot with multiple stories. So we had to excavate between that 25, 30 feet limited area using using an equipment with special attachments to be able to limit the exposure and also to be able to reach down for 40 feet. Other than that, also we continuously live monitor all these structures to make sure they're staying in place, they're not moving. The second area is working inside the yard and the shop. Because the operations, we have to work off hours and we have to work on the weekends to minimize our disturbance to yard operations. Again, similar to outside, we had to resequence our work because there were limited underground space, and we had to move several times between different locations to fit our large equipment like pump stations, oil water separators, etc. And also navigating yard operations and other contractors. There were at one point, I think, more than 5 contractors working in this yard. I mean, the success to this job, I think, is the work collaboratively to resolve the issues as they arose, because we were working on a track outages, and you have to, resolve and find a solution right away within limited days. So we got on the call, we got on the table, we got on the same room, and just to find the best solution to get the job moving. I mentioned several stakeholders already, like Con Ed, Level 3, Verizon, ECS. As you can see on the photo on 215th Street, we had the sanitation and then the double, triple park their equipment. They're needed. I mean, especially wintertime, the snow plowing, they lay their trucks out there, so we have to coordinate that work closely with them. Those stacks had to be removed, so construction was going on there, so we were working with them closely. State and city agencies, this is an MTA job, but basically we're doing sanitary sewer, so eventually it's being turned over to New York City DEP. So the close coordination with DEP, New York City Transit, New York City DOT, and for emergency responses with FDNY and NYPD. I mentioned that with the community board before, so we worked with them closely for outdoor seating or access to buildings that we need to excavate or install our SOE system. And with that, I guess turning over to Eamon to close it up.
Well, this project defies the normal for construction projects, for large construction projects, that it was finished on time, actually ahead of time, and about 6% below budget. The reason for the success was the one-team approach. You can see the graphic that I made here. A typical approach is a hierarchical approach, and this approach we kind of all worked to the same with the same capacity. All of us worked for the project. We were aided by the idea of co-locating. We had the same office where we can walk and talk with each other and coordinate with each other. We basically saw each other every morning. It was right next to the yard, and all of us worked together. The folks behind me and myself, we were all engaged from day one, so there was no change at the leadership of the project, and that carried to the other team members. So everybody on the job, almost everybody was there from day one. That's from 2019. We also tried to experiment with the use of new technologies. We used drones, LiDAR, ground-penetrating radar. We used some sensors for curing of concrete, as well as we use AI tools to script all our meetings. and the pandemic benefited us where all of the other stakeholders, we were able to meet them online rather than traveling and losing time to travel to people. Sustainability was at the heart of the project. My father taught me something related to medicine. He's a physician. He was very disappointed that I became an engineer, but he wanted me to, when I built, to make sure if you build a hospital, you don't include material that could cause cancer for like a hospital that treats cancer. Same with sustainability. When we looked at the material, we tried to use responsible material and equipment as much as possible. If you saw the pictures, we worked on the streets, so we had to redo the streets, most of them, and the curbs. So we used recycled green asphalt. We also used electric equipment wherever we can, and when there was none available, we used a Tier 4 diesel emission equipment to continue work with the sustainable approach for this project. And finally, I wanted to talk about the strategy for future resilience. I will sum this in as few words as possible. Floods and hurricanes are here to stay. They've been here since the formation of this earth. And the way that we deal with them, the water will always rise. 6 inches of water could carry a person. If 1 foot could carry a car, it could do a lot of damage. But with engineering ingenuity, with the will from folks, we can design structures and build structures that could rise above the water. Thank you.